let's go ahead and get this started. So today's webinar, we are going to dive into those concepts of, entrances. And when we talk about entrances for a home, right, that's typically doors, whether, they're whatever type of door it happens to be, but there are other openings to think about. They may not be entrances for humans or a typical traditional type of openings for humans, but there are various types of openings to think about, and how do we address those types of openings too? Because the idea is, we want to ensure that we're maintaining the integrity of that thermal envelope, keeping that conditioned space where we want the conditioned space to, or the conditioned air to actually be. And the other thing that I want to talk about, which we don't talk about very often, are sunrooms. So the first question I have for you all is, how many of you deal with sunrooms? Raise your hand. Oh, all right. Well, I see a few of you. So we're going to have the conversation about sunrooms, and then we'll finish things up talking about the commercial side of things of vestibules. And I brought vestibules into this conversation because when we start talking about, the differences between residential and commercial, a lot of times we have multifamily, and in a development, we might have multifamily projects that are considered residential by the energy code. And then right across the little driveway there would be a building that would be considered to be commercial with the energy code. So I wanted to kind of bring in that concept of the vestibules, because sometimes whether the energy code considers it to be residential or the energy code considers it to be commercial, a lot of times they both will contain vestibule type of concepts. So I thought we would talk about it so that we ensure that when it is commercial, you're getting the vestibules that should be designed and installed by code. So with all that, welcome, and let's get down and have some fun. So the building thermal envelope, which I know you're like, gosh, Hope, you have never ever uttered those words before. What are you talking about? And we know that the building thermal envelope is basically dealing with where it's the basement walls, exterior walls, floor, roof, and any other building elements that enclose conditioned space or provide a boundary between conditioned space and exempt space or unconditioned space. So the items that are called out by this definition, are the walls, floors, roof, right? But there are other components that are part of this thermal envelope that were not specifically called out. And I think probably one of the first two items that really pop in all of our heads is, right, doors and windows. We all know that those are part of that thermal envelope. But sometimes people aren't always aware of that concept of, the skylights. Skylights are a part of that. No worries, Guadalupe. You'll hear me chat some more later. So we have skylights. Now, another part of the building thermal envelope, which you guys alluded to, that some of you really do have to worry about, are those sunrooms. Now, sunrooms may be part of that thermal envelope, or they may be, outside of that thermal envelope. And we'll talk about that in much further detail. But the one other thing that I want to bring to your mind is, you know what? We have inlet and exhaust air that's constantly being provided, throughout our buildings with our mechanical systems and so forth. And so there are some things that we have to think about, those types of entrances, those types of openings, and how do we address that, when we start talking about the energy code. And so the reality is, we always want to welcome people into the structure, right? That's the idea, is laying out the welcome mat, getting people to come into the house, getting people to come into the building, whatever the case may be. And to do that, that requires, that concept of doors, right? And I think we have probably all had the quote unquote discussion of, you know, our parents, our grandparents, whatever the case may be, telling us, quit leaving the door open. You're heating up the outside, or I'm not heating the outside, right? We've all had that conversation. In fact, I'll admit to the fact that I know I've told my kids plenty of times, shut that door. So we want to have that opportunity to let people in the building, but we also want to ensure that we have every possibility of keeping whatever that conditioning inside the structure itself. Now, I find this incredibly important because on Sunday, and it was incredibly cold here, and I'm sure you guys got the cold too. Our boiler went out. So we had no heat, in the new house, and we couldn't get anybody who was going to be able to come out until Tuesday. So we were doing everything within our power to ensure that we kept the energy and all the conditioned air that we had inside the building and keeping it, as best that we could, which included things like, passive concepts, right? We kept all of our blinds closed for our windows to ensure that we were trapping as much heat as we possibly could in the areas that we wanted it to be there, because second law of thermodynamics, heat is always going to go to the cold. And when it's, a -2 outside, obviously the heat wants to go out there. So now we have to think about, when we're talking about these types of doors, what kind of doors are these? So there's really two door types to think of. We got our opaque doors, and opaque doors are doors that basically you cannot see through, and at least 50% of that door is going to be opaque, because we have a wide variety, right? We've got metal doors, wood doors, and then we also have this thing called like glass doors. So when we have a door that happens to be more than 51% or 51% or more of the door is glass, it's considered to be vertical fenestration. Now, vertical fenestration is fenestration that is more than 60 degrees from horizontal. So obviously our doors are going to do that. Now, in this particular instance, when you look at this door, do you call this door a fenestration, or would you call this door an opaque door? So my question for you all, raise your hands because you've sat there now. How many of you call this door an opaque door because it's more than 50% opaque? Okay, raise your hand if you say that it is a fenestration. All right, good job, Robert. You're right. This door is more than 50% glass. So because it's more than 50% glass, we're looking at that we would pay attention to the requirements of the fenestration than we would the requirements of the opaque door. So there we go. So now that we are looking at these doors and we talk about the different requirements that we're going to find, this is the table. Now, this is the 2015 edition of the table, but the concept is still going to be the same whether you're on the 15, the 18, the 21, 24. The numbers might be a little bit different, but the concept is still the same. So now we're looking at the fenestration. So the door that is on the left hand side, we're looking at that fenestration U factor, which is the 0.35. If we look at the door on the right hand side, now we have to maintain the integrity of that door when we're talking about this. So what do we look at? Whoops. So we have to pay attention to those types of things. And I don't know why this is doing that, but it is. Yay. Okay. So we've kind of gone a little bit about what type of requirements that we have now. When we talk about those opaque doors, if you go into res check, right? Res check asks you what's the U factor for those doors. Now, there is nothing in this table that talks about the R value of the door, because the R value is associated with the insulation, and insulation is not being placed up on that door, right? They are looking at it as an assembly, which would be that U factor concept. And so because we're talking about that U factor concept, when you go into res check asks you what that U factor is. So instead of the U factor of what a wall would be, where you're talking about, you know, your exterior sheathing and your insulation between the cavities and this, you know, the stud values and then the gypboard, and you add everything up and get to your U factor. That's it's similar concept with that, but those doors could be, you know, like in this one, it may or may not have some insulation between the two panels of metal. It might just be air, or it could be solid wood, or honeycombed, right? There's a lot of possibilities of what that U factor would be, but when you go in and you put the value into res check, it does the calculations to ensure that basically you are, you know, maintaining the integrity of that thermal envelope and that you're trading things off appropriately. Now, the really good thing is there is an exemption, and the exemption is that one side hinge door, opaque door, right? So we're talking about, you know, can't see through door, up to 24 square feet is exempt from the U factor requirement that you find within table R402.14 or 402.1.2, depending on what edition of the code that you're in, which is that U factor that we just talked about. And the reason for that is kind of like, hey, we know that a lot of times you might have this beautifully intricate front door. And basically this exemption, it doesn't say that it has to be the front door, but it is a side hinge door. And typically the front door is a side hinge door. And sometimes you want to do something really wonderful with that front door. And this gives you the opportunity that this particular door could be exempt from it. It could also be the door separating the garage from the dwelling unit, right? If that garage is unconditioned, that door between the two could be one of the doors that are exempt. But either way you look at it, you do have the exemption of up to 24 square feet of doors. Now, we talked about that concept of opaque doors. And when we talk residentially, there's not a whole lot in the energy code when it comes to opaque doors for residential projects, other than that exemption. Now, that exemption is only allowed if you're going with the R value option of the prescriptive path. So if you're going with res check, or you're going with the U factor option, it doesn't allow for that exemption. That is where you're going to start doing, you know, the trading option of the thermal envelope. I just wanted to jump on back to that. So now when we talk about probably the second most thought of opening in a house, we're talking windows. Now, windows can fall under one of two categories, right? Fenestration, I should say, can fall under one or two categories. They can either be considered vertical fenestration, which, as I mentioned before, is if they're 60 degrees or greater from horizontal, then they're considered to be vertical fenestration. But skylights are, if there's less than 60 degrees from vertical, then they're considered to be a skylight. So you could potentially be looking up, and depending on the slope of the roof, that skylight might not be considered a skylight. You may call it a skylight, but now it's vertical fenestration. And if you look at it, you're going to have different requirements, right? So if we come over here and it's 60 degrees, we know that our vertical fenestration that's installed in the roof would have to have a 0.35 U factor, or 0.32 or 0.30, depending on which code edition that you're on. Or you could have, if it is truly less than 60 degrees, then you could have a true skylight as defined, and it would just be the 0.55 for that U factor. That's a big difference, right? Because I'll tell you, I have seen skylights, because a lot of people are like, wow, did you see that skylight? That skylight, is calling out that it's going to be a 0.35. Well, yeah, it says 0.35 because they want to ensure that that skylight, no matter the slope of the roof that it's being installed in, qualifies it to be able to be utilized, no matter what slope it is. Now, the other thing to pay attention to, no matter which edition of the code that you're under, is the sheer fact that we have to talk about that solar heat gain coefficient. So windows, we want to ensure that we don't allow the solar radiation heat to infiltrate through the window and heat up the space unintendedly. When we have locations that are more cooling dominated than heating dominated, we don't want to add that load to the cooling side of things. So that's why you have a solar heat gain coefficient here, whereas if we looked in climate zone 7, there's no solar heat gain coefficient requirement there. That was kind of my question. How would that skylight, not really a skylight based on definition, be calculated in the heat load gain calculation? That's a great question. But when you go into one of the Manual J softwares, whether it's RightSoft or Elite or Cool Calcs, whatever type of software a designer utilizes, what they would do is when you go in and you put that information, you're either classifying it as a skylight because it's less than 60 degrees, or you're classifying it as fenestration, and it takes that into account. So you're going to qualify it and say, hey, I got a 2x6 skylight and the U factor is 0.40. I'm just obviously throwing out numbers and so forth. But that's how you would incorporate that into the calculations for that heating and cooling load. Now, because you don't have that solar heat gain coefficient requirement with that, it may have more of a load to it than you might think. But when we look at these numbers, we have to keep in mind that you're looking at these, and it is not just the glass, right? It's not the center of glass. It's the entire assembly that makes it work in the fashion that it works, so that we get that 0.30 or we get that 0.4 solar heat gain coefficient. So if we notice on the right-hand side, here's a very detailed breakdown of what a glazing would entail. We've got the sash going on, we've got the glass going on, we've got spacers going on that, it's illustrating where all of these components fit into this calculation. And then if you look on the left-hand side, I was really lucky. I was doing, I was sitting on a panel for some builders, and it was at a glazing manufacturing location. They had the little training session, so they were having it there. So they had these already out there, and I'm like, I'm taking pictures like crazy, and I'm sure they probably thought I was some crazy lady. Why would you take pictures of that? I take pictures of that because then I get to show you all the fun that I have. So you vicariously get to enjoy those images with me. All right. So let's talk about these windows. When we look at these stickers are our absolute best friend in the whole entire world, right? These pictures, or these, not pictures, these stickers allow for us to get the vital information we need. You know, our U factor, which we have to pay attention to, our solar heat gain, we have to pay attention to. Now, it also provides information about our visible transmittance, and it also lets us know how much air leakage this window tested at, because believe it or not, we got requirements for it, and we'll talk about it. Now, the other thing it does state is this happens to be an Energy Star certified window. Now, when I say that, and we see this image right here, it's shown right here, and most stickers will either have it or not have it. If it's not an Energy Star window, it's not going to have this. But if it's an Energy Star window, it's going to show this. But what it tells us too is if we look at the shading of these, the region, that shading is the only locations that this window is considered to be an Energy Star window. So for you all, it's kind of close, right? How many of you would say that when you look at the shading, you're going to consider your location as these windows are Energy Star windows? Raise your hand. Yeah, I agree, Michael. Yeah, Robert. I think that shading would cover, you know, most of our areas down there that would indicate that this is an Energy Star window. Now, what I will say is, like I said, if it doesn't have that in here, then, you know, then it isn't, you know, it doesn't qualify for it, whether you're, you know, the shading or not. That the box right here that this is at is just a blank white box. That's all it is at that point. Now, the other thing to keep in mind, and you're like, why do I care whether it's an Energy Star window? Because there are programs out there that it's required that they install Energy Star windows, and there are locations that actually have laws now saying that the windows that are getting installed have to be Energy Star windows. Not necessarily, you know, in your location, but it is something to be aware with. If they go with the Energy Star program, they are required to have that, right? So there we go. Now, here's the really fun thing. So let's pretend that, you know, we have some windows. The code allows us that instead of just ensuring that everything is a 0.30 and nothing can be less than that, it allows for a little bit of flexibility. Now, this flexibility has been built into the code for many, many editions. And in my opinion, it's really able to be utilized now, especially when you start talking about for alterations and so forth. And it's this area weighted average. And basically what you're doing is you're taking the amount of area of a certain type of window, their U factor is 0.30, and then you got a certain amount of area that this is 0.32. And when you average all of that out, it equates to a 0.31 type of deal. You know, obviously it's a little bit more complicated than that. But The code allows for you to do that for your U factor. It also allows you to do that for your solar heat gain coefficient. Now, it doesn't just outright allow it no matter what. If you're going with res check, it doesn't allow you to do the area weighted average. But if you're going with like just going R value of the prescriptive path, you could utilize this area weighted average, or if you were an existing building and you're doing an alteration or an addition or something of that nature, then you could utilize the area weighted average for it. Now, it also talks about dynamic glazing. Now, dynamic glazing is where, you kind of have the shades. It has that, I don't know. You know what? I don't think I put it in here, but it's where the amount of sun determines, whether the blinds are up type of deal. So let's look at what an area weighted average concept would be. So if we took, what we see here, we have two types of windows. We got one window that has a 0.30. So we take that 0.30, and when you add up all the window area, it equates to 150. So we take 0.30 times 150. That gives us 45. Then we take the second window type, and it happens to be a 0.45, and we have an area weighted average, or where we, did the area, and it's only 50 square feet or square inches, whatever it is. And so we multiply the 0.55 times the 50, which gives us 22.5. So now when we take 45 plus 22.5, that gives us 67.5. Now we're dividing it by 200. And you say, well, where'd the 200 come from, Hope? Did you pull it out of the air? And I'm going to say, no, actually, what we did is we took the area value of the window type 1, which was 150, and we added the area type 2, which is 50. So 150 plus 50 is 200. That's where we get the total area that we're dividing it by. So when we divide 67.5 by 200, it equates to a 0.34. It's like 0.34652 or whatever the case may be. I did it as a 0.34. And there we go. That's how an area weighted average is equated to be able to utilize it. Now, just like with the opaque doors, windows have an exemption to it. So if you have 15 square feet, you are allowed to exempt the U factor and solar heat gain coefficient that we find in our table. Now, the only thing is you can only use that 15 square feet if you're going with the R value option of the prescriptive path. If you're going, res check or the U factor option, you don't get the ability to have that exemption. While there is flexibility, it's flexibility if you are just going with the R value option. And the idea was that those little bump out windows right by the kitchen sink, a lot of times those windows were utilized for, growing herbs or whatever the case may be. It was for plants. And, many, many years ago, windows were not necessarily conducive with creating ideal environments for plants. So they wanted to ensure, hey, we'll still let you have your herb garden, but the rest of the house has to be energy efficient. So a little bit of thoughts there. The other thing to keep in mind is, as I mentioned, there is some requirements when you start talking about that air leakage rate. So basically most windows, skylights, sliding glass doors, all of them cannot exceed the 0.3 CFM per square foot. Now, if you happen to be a swinging door, now that's a swinging door that's glass, not an opaque door, but a swinging door that's glass. It says that you cannot be greater than 0.5 CFM per square foot. Now this, again, you're going to see it listed as soon as my arrow shows up. Down here within that sticker has like the 4 boxes. The upper right is your U factor, the the upper left is the U factor, the upper right is the solar heat gain coefficient. Down below it is your visible transmittance. And to the right, there is your air leakage amount, that what it tested to. So with that being said, the visible transmittance, while it's not necessarily, I guess, really thought of on the residential side or the energy side at all, is because, for a long time ago, for them to be able to hit the numbers that they were hitting, they were shading the window. That's not what I want to call, but sunglasses, you have that coating on the window or on your glasses that, are darker. So those windows were darker. And so in having those windows darker to meet those requirements, we got to remember, we also have building code requirements that says, hey, we have to have so much natural lighting that comes in. And so we had to ensure that we weren't impeding that. So that's kind of that visible transmittance concept for it. So here's where we pay attention to the U factor, we pay attention to the solar heat gain coefficient, we pay attention to the air leakage. This is saying that it does not exceed that 0.3 concept for it. But if we look over here, you'll notice that this one has no information about air leakage. So because it doesn't have the information for that air leakage, if it doesn't have something listed there, it actually should not be installed unless they have something that says, something to the contrary, product information. No, it meets that. I don't know why it wouldn't be listed there, but it does have to meet, very specific standards. So maybe it didn't get an NFRC 400 rating to it. But we should always see windows where this bottom right-hand number is shown, and it's shown to not exceed 0.3 here. And it does here. And here's another example where it has Energy Star windows, and it does appear to be in your location. So something that I do think often gets forgotten about is, a long time ago, we all have windows. We all want windows. Well, maybe not everybody, but many of us enjoy having windows because it allows us to look out the window, kind of feel like we're outdoors and, still have the comforts of, hey, it's only a -2 degrees outside. It looks really nice out there, but I'd rather stay inside and be slightly protected here. And so one of the things that, used to happen, in almost every house design was the concept of those overhangs or really large wraparound porches, right? And the reason for that is because that gave us this concept of kind of a passive concept of allowing us to have, windows and everything, but yet still protecting us so that we're not 1,000 degrees as we're sitting in this room. And the idea is when you have a really long overhang at, at a good angle, then in the summertime, when the sun is really high, it's protecting the sun from adding all that additional heat load to the structure. But yet in the wintertime, it's allowing, because the sun is lower in the sky, it's allowing some of that heat to penetrate into the structure. So then the structure isn't having to heat as much. So it's kind of this like win-win situation that I think a lot of people have forgotten about, that we didn't always have air conditioners. And this is how old I am. I remember I used to spend my summers in Phoenix, Arizona, because that's where my grandparents live. I don't know if you know this, but it gets a little warm in Phoenix, Arizona in July and August. And there was an awful lot of covered patios back at the, where the back door would be, and really long covered front doors. And in fact, a lot of times you had like carports where the cars would kind of block the entrance, but you had this big covering over it to ensure your entrance door, was a little bit of protected. So, those concepts hopefully will maybe come back around and will not rely as heavily on mechanical equipment. But I remember those days, and I remember the first evaporative cooler that my grandfather got for the house. That thing, man, did we love that room that it was in. We hung out in that room, but man, if you opened that door and you were not out immediately and did not immediately shut the door after you, did you hear about it from my grandparents? Holy cow. All right, so let's talk about the concept of those sunrooms. So sunrooms, if you're under the 2015 edition of the Energy Code, has some kind of like leniency built in, flexibility that's built in to it. And the really nice thing is if you're on the 21 or the 24 code, it not only includes sunrooms, but it includes that flexibility. If you happen to have an attached conditioned garage, you can also utilize some of these practices for it. But it's only in the 21 and 24 that the garages comes into this. But here's a great example of a sunroom, right? You have the ability that you have all this glazing in there and you get to see the outside, but with the comforts of, kind of being sheltered and protected. Now, for it to qualify as a sunroom, there are some specific parameters that it has to follow. And part of those parameters is ensuring that, one, it's only a single story structure, and it's a single story structure that happens to be attached to the dwelling unit. So it's not a greenhouse, right? It's not a ADU that is all made of all glass, It's really a extension of the house itself. And it also, the parts of the exterior walls have to be at least 40% of those walls and roof has to be glazing. So it has to be fenestration, whether it's this way or this way. It's got to be 40% of it is glazing. Now, the nice thing is, one of the things that it talks about is if this space is thermally isolated from the conditioned spaces, meaning basically that, let's see. So in this scenario, we've got these walls, right? We've got 3 walls basically, and this back wall that isn't seen would be attached to the house, would be the house, what was the exterior wall there. So in that exterior wall, it would have to be thermally isolated from all of that conditioned space. Now that wall probably is a wall and has a door, because that was your entrance door, that was your back door type of deal. In that scenario, that would be considered to be, thermally isolated from that conditioned space. That would mean, the door is weather stripped and all that fun stuff. We're really trying to maintain the integrity of that thermal envelope. Now that sunroom, how they're addressing it, it's not saying you have to have the R20 in the cavity or the R30 in the cavity, depending on, which code cycle you're on. What it says is your walls only have to have an insulation value of an R13. And it also says that your roof, it doesn't have to be an R49 or an R38 or an R60. What it says is you only have to insulate that roof line or ceiling line to an R19 value of the code. So we're not looking at this. What we're looking at is this. And that is a nice difference when we start talking about some of that. And like I said, in the 21 and the 24, it also includes that conditioned garages could follow the 1913 option as opposed to the 60 and 30 option. Now, another component is because it did say 40% of the walls and roof had to be fenestration, had to be windows. So what the code says is, yes, it does have to have a certain percentage of fenestration, but that fenestration doesn't have to be at a 0.35 or a 0.32 or a 0.30. The only thing that it has to be is a maximum of a 0.45 U factor. And then if you have the skylights, right, because they're less than 60, which a lot of times you have where those sunrooms have, you know, a large amount of skylights in it, then instead of the 0.55, you can go all the way up to a 0.70. Now, just so that we're completely aware, this is talking about, like, we're just going to say it's well, we're going to do it this way. So we're going to say, here's the house, right? And then here's our little sunroom, right? So they're saying that this, you know, this is all part of the sunroom. Now, what it's saying is new fenestration that's separating, you know, the conditioned space here from here. So if we have windows located in this space, these windows would be required to comply with the 0.35, 0.32, 0.30. But if there's windows here, which there would be, right, because it's got to be 40%, windows in these locations would only have to meet that 0.45 for it. I hope that makes sense. So here's an example of, you know, a sunroom. It's a very interesting sunroom. It's a long, skinny sunroom, and they have their plants in there. And I don't know if you can see on the other side of the door, there's a chair there. This is basically one enormous sunroom where it is a house of glass, right? That's that, how does that go? Don't throw the first stone in a house of glass, or I don't know. Don't cast the first stone when you live in a house of glass. I don't know. But this would definitely be that case. But the nice thing is, one of the things that they incorporated into the sunroom, understanding that it is a sunroom and it does have less protection from the sun, they also included these shades. So if they needed to, you know, kind of offset some of that heat that's coming in there, they can. Now, these values, it doesn't say that they have to only go with the 0.45. They can always do better, right? Maybe they do just want it to be 0.35 or 0.32 or 0.30, because the idea is, let's make it as energy efficient as possible, because I want to be in that room and I want to enjoy that room. I don't want it to be a sauna, right? So nothing says that they couldn't put those windows in. It's just if they choose to, they can. That's one of their options that they got. The other thing to keep in mind is, remember I talked about inlets and exhaust, right? We've got to ensure that we have dampers going on, because those are openings that and entrances that I don't think we necessarily think about all the time, right? But they are an entrance for air to move in and out of the place, just like people move in and out of the place. And air definitely doesn't shut the door on when they're going in or out of a building. I don't know. Air just does not cooperate in the least bit. So really quickly, I just wanted to kind of bring up the concept, you know, we have those whole house mechanical ventilation systems. So not only do we have exhaust that would be, you know, like for an exhaust fan, we have the requirement of the whole house mechanical ventilation. And it tells us that, you know, we got to have something going on because we're building tight and we want to ventilate right. And to do that, that's how the whole house mechanical ventilation, you know, comes into play. And you have three strategies available. Most people, I will say, probably utilize the exhaust ventilation because it's one of those, you're already doing it. Although I'm seeing more and more people going with that balance, which would be an ERV and an HRV, because they look at it and it does so much more that it makes more sense to go that route. But if we have exhaust, we got to think about how we are exhausting this out and what are we doing to ensure that we're not leaving a giant opening for air to move freely, right? So here is where we need to talk about whether we're talking residential or commercial. So here is a building. It's multifamily, obviously, in a development. Now, our 2s, our 3s, and our 4s that are 3 stories or less would be residential. So this building itself would be residential. But if you turned around in the opposite direction, you've got this one being built and it's commercial. And I bring that up because a lot of times what they do for the commercial side, they might carry over onto the residential side, or they carry it over to the commercial side about what we see on the residential, when we know that there are different requirements when we talk about residential and commercial for energy, and especially when we are talking about entrances. Now, here is a prime example. This one happens to be a commercial multifamily building, but you notice that down here, we've got our entrances. Now, this entrance really should have a vestibule. And I just want to quickly kind of talk about vestibules a little bit, just because we have to understand that, you know, this one happens to be commercial, but you go across the street and it's residential. They still have that same design of a quote unquote vestibule, even though residentially it's not required. They have that vestibule concept. So let's look at what vestibule requirements are and the concept behind it. So vestibules for commercial projects, commercial by energy code, you're required at all building entrances. That means where the public comes in to the building, not doors that are there for exiting, right? Because we all know we have a certain amount of exit width that's required dependent on the occupancy. Well, obviously these 2 doors in a very large hotel or a very large multifamily project isn't going to be enough. So we have to have additional doors. And what this is saying is it's only the doors that is intending to get them into the structure and not out of the structure are required to have vestibules. Now, those vestibule doors have to have self-closing devices and ensure that the interior and the exterior doors don't open at the same time, you know, as much as possible, because we all know that people are coming in as people go out and those doors may be open. But in theory, if one person is opening the door to walk through, that door opens and closes before they get to the other set of doors where they open, and it does the same. Now, revolving doors are not required to have vestibules, but the doors that are adjacent to revolving doors, because the building code does say, hey, you can have a revolving door, that's fine. But you also have to have a side swinging door adjacent to that revolving door to allow people to come in. So it doesn't require a vestibule at the revolving door, but it does at that adjacent door. There's some exceptions. 0, if you're in climate zone 0 through 2, it's not required. Doors that are not intended to be utilized for the public, you know, those maintenance door or, you know, mechanical doors, utility doors, those doors that are really just there for employees to go in and do as need be, or for workers to go in, you know, type of deal. That's what this exemption is referring to. Doors that directly open from a sleeping unit or a dwelling unit. So let's say we have this multifamily project, right? So we're not required to have vestibules at my apartment door that goes, from the dwelling unit into the corridor, but the main entrance to get into my multifamily apartment complex, that would require a vestibule. Now, doors that don't open into a space that's 3,000 square feet. So in this particular instance, this little coffee shop, it's not large enough to require a vestibule. Now, we talked about revolving doors. This does not have to have a vestibule because if you think about it, this is kind of a self-contained door vestibule situation. But these doors that are required to be installed that are adjacent to that revolving door, there should have been a vestibule installed there. Doors, when we're talking about that are really just being utilized for, vehicles, and we're talking about, obviously we wouldn't have a vestibule door at a maintenance bay, right? Doors roll up because it's a door. So that wouldn't be it. But in this particular, situation, we got the truck coming in, we've got the weather seals, the strips along the sides that help with air infiltration, but it allows for, people to unload the truck or load up the truck, whatever the case may be. So that's not required to have a vestibule. And then you do have the opportunity to install an air curtain instead of a vestibule. And this came into the code because prior to the 2015 edition of the IECC, if you were an existing building, you basically had to comply with everything that was in the energy code as if you were a brand new building, with a couple of exceptions. In the 2015 edition of the IECC, they created that new chapter of Chapter 5, but this also came in. And the idea was that air curtains could be installed in lieu of a vestibule for those existing buildings, because sometimes you might not have the configuration to be able to add a vestibule once you start talking about all the requirements. Because a vestibule, while the energy code does not necessarily state how large a vestibule has to be, the building code and accessibility code does talk about doors in, concession. And so this door open has to have a certain distance from when this door is open to ensure that there is maneuverability between this door and this door. So while there isn't a set number of how large a vestibule has to be, there is some concession to that by when you look at the other code. Now, if you look at this, would you call this an air curtain and say that it meets the intent? The fan turns on when the door is open and the fan turns off when the door is closed. So how many of you would accept this? Raise your hand. How many of you would not? Raise your hand. All right. So in this particular location where I took the picture, this restaurant is in a jurisdiction that does not have building codes. It's one of those rare jurisdictions, but they do understand. And so it does work that way. It just hasn't been tested to necessarily have the testing values to it. So I think it meets the intent. Whether it meets the code to the letter, I'd probably say not. All right, so here's an example of, some vestibule doors, and you can see that this door is open while this door is closed. Now, when I went to take the picture here, this is at a hotel, I guess you could guess by the luggage rack there, but I kept opening the doors and then standing back so I could take a picture to show, this door is open while those doors are not. And the doors kept closing on me by the time I was turning around to get back far enough so I could get the image. And finally, the lady at the front counter, probably after she giggled a few times, I don't know, maybe not, she came out, she goes, let me help you. And so she pushed the button to the door, and so that I could take a picture of what I was trying to do. It's all about teamwork, right? So here's an example of a vestibule for this multifamily project. Now, if you notice, we got these two doors that are here. They did have, self-closing on them, but it doesn't just talk about this door and this door. This vestibule also has this door from the exit stairs that go out the door, which is common. It also has this area right here. And this area right here is a sliding glass door that opens up into where that leasing area is. So this is all considered to be a vestibule. So that means this is a self-closing door, this is a self-closing door, this is a self-closing door, and this is a self-closing door. So those are all things to just kind of be aware of. Here's an example of a vestibule that was at a hotel, another hotel. And then we saw this picture. So that's it. Anybody have any questions about vestibules or any entrances that come up? Always feel free to reach out to Josh or myself. Josh will be back next week for the webinars. It's been a wonderful pleasure to chat with you all these last couple of weeks. Miss chatting with you. And we're hoping soon that we'll be able to get